Good morning everyone. In the last lectures, we have discussed how to solve linear programming problem by using simplex method involving two decision variables. Today we are going to consider the example of three decision variables in the linear programming problem and solving the same by using the simplex method. So, the first steps towards solving linear programming problem by using the simplex method is to constitute a standard form which is the baseline format for all linear programming problems. So, of course, the standard form is necessary because it creates an ideal starting point for solving the simplex method as efficiently as possible. So, the standard form we need three requirements. See, the first one is objective function, and here we have to identify what actually our objective function is, whether it is maximization or minimization, by specifying our decision variables. After identifying the objective function, then the second step is all linear constraints must be in inequality form. So, here we will identify what are the various constraints or limitations on the given problem, and accordingly we will express it is either in the form of greater than equal to or it is less than equal to forms. Then after specifying our constraints, see, the third step is that all the variables are non-negative. That means here our decision variables must be greater than or equal to 0. So, we need a positive value for the all decision variables. So, this is the standard form of a linear programming problem. So, here we are going to consider a particular example, which is the example for the maximization of profit. So, here we are specifying our objective function, that is the maximization of profit, and our function that is maximizing z is equal to, for example, here we are considering the maximization of profit, that is z is equal to 3x plus 2y plus z. Here we have three decision variables are there, that is x, y and z. See, after specifying the objective function, the next step is to identify what are the various constraints. So, here this given maximization of profit function is subjected to certain constraints. So, here the constraints are 4x plus y plus z, which is less than equal to 30, 2x plus 3y plus z, which is less than equal to 60, and the third one x plus 2y plus 3z is less than equal to 40. So, here our problem is the maximization of the profit, thereby our inequality sign is less than equal to. This is the standard format for the maximization of a particular function. So, after identifying are the constraints, see, the next step is it is non-negativity of the constraint variable, that is our decision variable x, y and z are the greater than or equal to 0. So, this is the formulation of the linear programming problem in the standard format. Now, after this we are going to solve this particular problem by using simplex method. So, the next step is to convert our given linear inequality constraints into a linear equation by adding slack variables. So, of course, we are already discussed what actually mean by the slack variables in the last lecture. Again, we are specifying here the slack variables are the additional variables that are introduced to transform them from inequality constraint to the equality constraint and transforming them into a solvable equalities with one definite answer. So, thus we are adding the slack variables to the concerned equation with coefficient 1 and add the slack variables in the other equation and give them the coefficient of the 0. So, we will specify it in the upcoming example. See, here we are going to determine our slack variable in the above example, that is the maximization of z is equal to 3x plus 2y plus z which is subjected to the constraints, that is we have three constraints here, and all the decision variables are greater than or equal to 0. So here first constraint we are going to consider here, that is 4x plus y plus z plus I am introducing or adding the slack variable here. See, here we are going to add three slack variables, that is S1, S2 and S3 to convert our given linear programming problem into a standard form. So that is it converting the inequality into the equality by adding the slack variables into given three constraints inequalities here to give these three constraints equalities. So we have three slack variable here, S1, S2 and S3. See here, for the first constraint we are putting the S1 here by providing the coefficient 1. So here the coefficient of S1 is equal to 1, and here 0 S2 plus 0 S3. We are putting the coefficient 0 for the S2 and S3 variable, which is equal to, see we are again converting here the less than equal to sign into the equality sign, that is equal to 30. Similarly, we can consider the second constraint, that is 2x plus 3y plus z, which is less than equal to 60. Now I am writing the same here by adding the slack variables and putting 0 for S1 and S3 and coefficient 1 for S2 also. So it will become 2x plus 3y plus z plus 0 S1 plus S2 plus 0 S3, which is equal to 60. Similarly, the third constraint, that is x plus 2y plus 3z, which is less than equal to 40. Now I am going to convert by adding the slack variables. So it will become x plus 2y plus 3z plus 0 S1, 0 S2 plus S3. That is the coefficient of S3 is here, it is 1. And we are converting this inequality sign, that is less than equal to, into equality sign, so which is equal to 40. Now we are considering our objective function, that is z is equal to 3x plus 2y plus z, and we are taking the 3x plus 2y plus z into the left side of this given equation. So it will become minus 3x minus 2y minus z plus 0 S1 plus 0 S2 plus 0 S3 plus z, which is equal to 0. Now after this particular step, we are going to set up this simplex tableau. That means after introducing the slack variables to convert inequality constraints into equality constraint, we are going to set up a particular table that represents the model, and it is used to check the optimality. So here the simplex table is used to perform row operation on the linear programming model, as well as in order to check the solution for the optimality. So here the tableau is organized in such a way that the coefficient corresponding to the linear constraint variable and the coefficients of the objective function, which are written in a tabular format. So here we are going to set up a simplex tableau by using our example. So here this is our example. We are made it in a standard form by adding the slack variables, that is S1, S2 and S3. Now I am going to represent this particular standard form in the form of a simplex tableau. So I am drawing here this tableau by considering first row, that is x, y, z. Three variables are taken here, that is x, y, z. Then our slack variables, that is S1, S2, S3. Three slack variables are there. Then b, which is denoting for the constants in the given constraint. Then the basic variable, which are S1, S2 and S3. Now after setting up the simplex table, we are going to represent these coefficients in the given table. We are going to give the coefficient of the each constraint. The first constraint will be considered in the first row, then second one will be considered in the second row, and the third constraint will be considered in the third row, and the last row will be consist of the objective function coefficients. So here I am going to write, see here, the 4, 1, 1, 1, 0, 0, 30. So here it is written the coefficient of the first constraint, that is 4, 1, 1, 1, 0, 0, 30. Then the second constraint's coefficient are 2, 3, 1, 0, then S2 coefficient, which is 1, again 0, which is equal to 60. Similarly, the third row is representing for the third constraint, and the last row which is representing for the objective row or objective function, which is minus 3, minus 2, minus 1, 0, 0, 0, and for the here we are assuming z is b is equal to 0. So now after setting up the simplex tableau, then the next one, that is, it is ready for check of optimality. So here we are set up the simplex tableau of the given linear programming problem. Then the next step is to check given solution is optimal or not. How we know the given solution is optimal or not? In order to check whether the given solution is optimal or not, by using the tableau, where we will look at all the entries in the bottom row of the tableau. We will look at all the entries in the last row, and that is all the values in the last row, that means which actually representing for the objective row, all the coefficients must be non-negative. That means it must contain the value which is greater than or equal to 0 in the case of a maximization of problem. So if a value is less than 0 or negative, it means that the solution is not reached its optimal solution. It means that current solution should be needed to be improved, and the simplex method proceeds to pivot towards the better solution. So we want to check here whether our given simplex tableau is optimal or not from the our given example. So here see, in the given table, the last row that will be considered for checking the optimality. So given table, the 3 negative values exist in the bottom row, that means minus 3, minus 2 and minus 1, which indicating that this solution is not optimal. Because of these negative values, we can say that the given solution is not optimal. If the tableau is not optimal, then the next step is to identify pivot variable or element through the interactive process to create a new table, and accordingly we can go for checking the optimality again. So here first we are going to consider the pivot variable. See, if the current solution is not optimal, of course in our example it is not optimal, then we want to improve the current solution. For that we are conducting pivoting. See, what do you mean by pivoting? Pivoting is an interactive process to form an improved solution. For this purpose, we are going to introduce two variables. One is entering variable and another one is departing variable. So to improve the current solution, we bring the new basic variable into the solution. We can call this particular variable as entering variable, and one variable is enter, then one of the current basic variable must leave. So here the basic variable we know these are the S1, S2, S3, that should be leave when one new variable is enter. So otherwise we would have many variables for the basic solution. So we call this is a departing variable. So here what actually mean by the entering variable? See, the entering variable correspond to the smallest or most negative entry in the bottom row of the table. So in the given simplex tableau, we have to check whether the smallest non-negative value we want to identify and pick up the smallest negative value in the bottom row, and that particular column is marked as a pivot column. Then after that we want to find out the departing variable. We can divide, for that purpose we can divide b values, that is constant values of the linear constraint, by corresponding value from the pivot column. So then we will get a test ratio, and this is considered as a departing variable. See, here the departing variable correspond to smallest non-negative ratio in the column, which is generally known as it is pivot row. So after identifying pivot column and pivot row, then we are going to identify such a variable, that is the intersection of row with smallest non-negative and the column with the smallest negative value in the bottom row will become the pivot variable, or it is popularly known as it is pivot element. So the coefficient at the intersection of the pivot row and pivot column is marked as a pivot element. So we will do all these things by using the example so that it will be more clear. So in our example, see, from our bottom row, this is the bottom row, or we can say that it is the objective row of the tableau, which is the new coefficient objective. So here we are going to pick up the negative value, smallest negative value we are going to pick up from the bottom row. So here it is -3, -2 and -1. These are the three negative values. So we are going to consider here the smallest negative value, which is -3. And this -3 corresponding to the column will be considered as the pivot column. So I am marking here, it is the pivot column. The first column will be represented as a pivot column. So this column is marked as a pivot column. Once the pivot column is fixed, then the next step is to find the pivot row, which can be found by dividing the b values of the linear constraint by their corresponding values from the pivot column. Then we will get the test ratio. So here we are going to calculate the test ratio. So b value here, that is 30, divided by corresponding value in the pivot column, that is 4. So 30 divided by 4, which is equal to 7.5. Similarly, 60 divided by 2, which is equal to 30. Then 40 divided by 1, which is equal to 40. Now among these three values, we want to select the value with smallest non-negative, which is the test ratio, which is the smallest non-negative test ratio. So it will be here, it is the 7.5, which is actually belongs to, it is the first row, that is 30 divided by 4, which is equal to 7.5. So the row corresponding to the 7.5 can be represented as a pivot row. So I am going to represent here, this is the pivot row. The first row will be considered as the pivot row. So after finding the pivot row and the pivot column, then the next step is to identify, pivot element, which is the value at the intersection of the pivot row and the pivot column. So here the pivot element will be 4. So I am identifying here, it is 4 is the pivot element. Now after finding out the pivot element, then the next step is, we are going to replace the old values with new values. How we are going to find the new values in the given entire simplex tableau? See, first row, that is pivot row. First we are going to find the new value for the pivot row in place of already existing values. So how we will get the first row? See, the pivot row, which is equal to multiplying each element by using the reciprocal of pivot element. So here the pivot element is 4. So the reciprocal of pivot element is 1 by 4. So we are going to multiply each value of the given first row, that is pivot row, by using 1 by 4. So it will become, see, 4 into 1 by 4, which is equal to 1. Then 1 into 1 by 4, which is equal to 1 by 4. Again 1 into 1 by 4, which is equal to 1 by 4. Then again we have 1 into 1 by 4, which is again 1 by 4. Then 0 into 1 by 4, which is equal to 0. Then 0 into 1 by 4, again it is come out with 0. Then we have 30 into 1 by 4, which is equal to 7.5. So now the first row we are going to replace with new calculated value. So it will become, see, 1, 1 by 4, 1 by 4, 1 by 4, 0, 0, 7.5. Now we want to again replace the second, third and the fourth rows. So how we are going to replace? See here, first we are considering the second row. So second row can be found, that means new values can be found, the old value minus corresponding value in the pivot column into new value in the pivot row. So here the old value, that is equal to 2, minus corresponding value in the pivot column. See, pivot column is this one. So here the corresponding value is also 2 into new value in the pivot row. New value here, it is corresponding value is 1. So here I am going to consider the first one, 2 minus 2 into 1, which is equal to 0. Similarly, the second element, that is 3 minus 2 into the new value, which is equal to 1 by 4, which is equal to 5 by 2. Similarly, 1 minus 2 into 1 by 4, which is equal to 1 by 2. Then 0 minus 2 into 1 by 4, which is equal to minus 1 by 2. Then 1 minus 2 into 0, which is equal to 1. Then 0 minus 2 into 0, which is equal to 0. Then we have 60 minus 2 into 7.5, which is equal to 45. So the second row now I am going to replace with the new values which we are calculated here. So it will become 0, 5 by 2, 1 by 2, minus 1 by 2, 1, 0 and 45. Now the third row we are going to find the new values. See here again we are using the same formula. So accordingly the old value, that is 1, minus corresponding value in the pivot column, that is 1, into new value of the pivot row, that is equal to 1. So it will become 1 minus 1 into 1, which is equal to 0. Similarly 2 minus 1 into 1 by 4, which is equal to 7 by 4. And the third one, that is 3 minus 1 into 1 by 4, which is equal to 11 by 4. Then 0 minus 1 into 1 by 4, which is equal to minus 1 by 4. 0 minus 1 into 0, which is equal to 0. Then 1 minus 1 into 0, which is equal to 1. Then 40 minus 1 into 7.5, which is equal to 32.5. Now we are going to replace the third row again by using this particular new values. Then it will become 0, 7 by 4, 11 by 4, minus 1 by 4, 0, 1 and 32.5. Now we have one more row, that is the objective row. So again by using this same formula, that is old value minus corresponding value in the pivot column into new value in the pivot row. So here it will become see minus 3 minus again minus 3 into new value which is equal to 1. So if you solve it, then it is equal to 0. Then the second one, that is minus 2 minus minus 3 into 1 by 4, which is equal to minus 5 by 4. Then the third one, that is minus 1 minus minus 3 into 1 by 4, which is equal to minus 1 by 4. Then 0 minus minus 3 into 1 by 4, which is equal to 3 by 4. Then 0 minus minus 3 into 0, which is equal to 0. Then we have 0 minus 3 into 0 again, which is equal to 0. And the last one, which is equal to 0 minus minus 3 into 7.5, which is equal to 22.5. So I am going to replace the old values in the objective row by using the new calculated values. So it will become 0, minus 5 by 4, minus 1 by 4, 3 by 4, 0, 0, 22.5. See, now we have a new simplex table here. Once all the elements of new table are calculated, then we are replacing the departing variable with entering variable. So what is the entering variable here? Our pivot column will be the entering variable. So here the pivot column corresponding here the variable is x, which we are going to replace with departing variable. Departing variable will be those variable or those basic variable which are corresponding to the pivot row. So here it will be S1. So S1 which is the departing variable here, and we are going to replacing S1 by using the entering variable which is x. So it will become C, x I am putting here in place of x I am putting here in place of S1. Now we have all the exercise we done here. Now the table is ready for the optimality check. See, to check whether the given solution is optimal or not, see in the given table, if all the values in the bottom row are positive or equal to 0, then we can say that the solution is optimal. But see here, we have two negative values exist in the bottom row, which indicating that the solution is not optimal. So what are the negative value here? Minus 5 by 4 and minus 1 by 4. We have two negative values exist in the bottom row, showing that our solution is not optimal. So if this is not optimal solution, then the next step is again go for the process of pivoting by identifying pivot element through interactive process to create new table. So again here we are going to consider, see, the smallest or most negative entry in the bottom row of the table. So here it is minus 5 by 4, which is considered as the smallest negative value in the bottom row, and this particular column will be considered as, it is pivot column. See, after identifying the pivot column, our next task is to identify pivot row as well. So for that, we are going to divide, see, this particular B values by using the pivot column elements. So here it is 7.5 divided by, it is 1 by 4. So here it will become test ratio 7.5 divided by 1 by 4, which is equal to 30. Then 45 divided by 5 by 2, which is equal to 18. Then 32.5 divided by 7 by 4, which is equal to 18.57. So here the test ratios are given here. Then here the departing variable corresponding to smallest non-negative ratio in the column, that is pivot row. So that is here it is 18, which is considered as the the smallest non-negative value, which is equal to 18. See, our test ratio here, the smallest non-negative value here, it is 18. So that is corresponding to the second row. So we can say that the second row will be considered as the pivot row, and here S2 will be considered as the departing variable, and pivot column, that is Y, will be considered as the entering variable. So we are marking here, that is pivot row, by highlighting by using the red color. And after identifying pivot row and pivot column, then the next we are going to identify pivot element, that is the intersection point. Here it is 5 by 2. So after identifying the pivot element as well, we are going to enter restructuring of the entire table by using the pivot row. So first we are going to consider the pivot row. We are replacing the old values by using the new value, which can be calculated by multiplying each element by using the reciprocal of the pivot element. So here the pivot element is 5 by 2, its reciprocal is 2 by 5. We are going to multiply each element in the pivot row by using 2 by 5. So here it will become 0 into 2 by 5, which is equal to 0. Then 5 by 2 into 2 by 5, which is equal to 1. Then 1 by 2 into 2 by 5, which is equal to 1 by 5. Then we have minus 1 by 2 into 2 by 5, which is equal to minus 1 by 5. Then 1 into 2 by 5, which is equal to 2 by 5. Then we have 0 into 2 by 5, which is equal to 0. Then 45 into 2 by 5, which is equal to 18. So now the old values in the pivot row we are going to replace by using the new calculated value. So it will become 0, 1, 1 by 5, minus 1 by 5, 2 by 5, 0 and 18. Now after finding the new values for the pivot row, then the next step is, we are going to replace the old values of the first row. For that we can use the formula, that is old value minus corresponding value in the pivot column into new value in the pivot row. So here it will become, see, 1, that is the old value, minus corresponding value in the pivot column, that is 1 by 4, then into new value in the pivot row, that is equal to 0. So it will become 1 minus 1 by 4 into 0, which is equal to 1. Then the second one, that is 1 by 4 minus 1 by 4 into 1, which is equal to 0. Then we have 1 by 4 minus 1 by 4 into 1 by 5, which is equal to 1 by 5. Then 1 by 4 again here, minus 1 by 4 into minus 1 by 5, which is equal to 3 by 10. Then we have 0 minus 1 by 4 into 2 by 5, which is equal to minus 1 by 10. Then again we have 0 minus 1 by 4 into 0, which is equal to 0. Then we have last one, that is 7.5 minus 1 by 4 into 18, which is equal to 3. So the first row now we are going to replace with the new calculated value. So it will become 1, 0, 1 by 5, 3 by 10, minus 1 by 10, 0, 3. Okay. So again now we are going to consider the third row. So third row again we are going to calculate the new values. So it will become old value minus corresponding value in the pivot column into new value in the pivot row. So it will become, see, 0 minus 7 by 4 into 0, which is equal to 0. Then we have 7 by 4 minus 7 by 4 into 1, which is equal to 0. Then 11 by 4 minus 7 by 4 into 1 by 5, which is equal to 12 by 5. Then we have minus 1 by 4 minus 4 by 7 into minus 1 by 5, which is equal to 1 by 10. Then we have 0 minus 7 by 4 into 2 by 5, which is equal to minus 7 by 10. Then 1 minus 7 by 4 into 0, which is equal to 1. Then the last one, that is 32.5 minus 7 by 4 into 18, which is equal to 1. So the second row, now we are going to replace by using the new values here. So it will become 0, 0, 12 by 5, 1 by 10, minus 7 by 10, 1 and 1. Now we have the last row, which is the objective row. Again we are going to replace the old values by using the new calculated value. So here how we are going to calculate the new value? That is old value, that is here 0, minus corresponding value in the pivot column, that is minus 5 by 4, into new value in the pivot row, which is equal to 0. So it will become 0 minus 5 by 4 into 0, which is equal to 0. Then minus 5 by 4 minus 5 by 4 into 1, which is equal to 0. Then minus 1 by 4 minus 5 by 4 into 1 by 5, which is equal to again 0. Then we have 3 by 4 minus 5 by 4 into minus 1 by 5, which is equal to 2 by 4, which is again we can simplify, that is 1 by 2. Then we have 0 minus 5 by 4 into 2 by 5, which is equal to 1 by 2. Then 0 minus 5 by 4 into again 0, which is equal to 0. Then the last one, 22.5 minus 5 by 4 into 18, which is equal to 45. Now the old values in the objective row we are going to replace by using the new calculated value here. So it will become 0, 0, 0, 1 by 2, 1 by 2, 0 and 45. See, once all the elements in the new table are calculated, now we are replacing the departing variable with entering variable. What is the entering variable here? See, pivot column corresponding to the variable will be the entering variable. So entering variable will be y. And what is the departing variable here? It is the pivot row variable, that is basic variable, that is S2 will be departing variable. So here we are going to replace, that is S2, which is the departing variable here, by using the entering variable, that is equal to y. So therefore here I am going to replace S2 by using y. So we have new table is ready. See, after doing all the exercise here, now the table is again ready for the optimality check. See, that is check whether the given solution is optimal or not. So in the given table, if all the values in the bottom row are positive or it is equal to 0, then we can say that our solution is optimal. So here, in the given table, 0, 0, 0, 1 by 2, 1 by 2, 0 and 45. See, all the values in the bottom row are the positive, or it is either it is equal to 0 or some positive value, that is 1 by 2, 1 by 2 and 45. We can say that we have an optimal solution. So yes, all the new values in the bottom row are positive or equal to 0, indicating that given solution is optimal. Now ultimately we reached the optimal solution through the interactive process. So this particular solution will be considered as the optimal solution. Now we are going to interpret this particular optimal solution. So here, as there is no negative elements in the bottom row, we can say that we have an optimal solution. Here x is equal to, see, x is equal to, it is 3. And value of y is equal to, it is 18. Sorry, value of S3 is equal to 1. So here we can say that there is no negative elements in the bottom row. Of course, our solution is optimal. Then x is equal to 3, y is equal to 18. Then S1, S2 are become 0. That is S1 is equal to 0, S2 is equal to 0. We have S3 here. So S3 is equal to 1. So we have a solution here, and we can calculate the maximum value. That is, our objective function was maximization of profit. That is, z is equal to 3x plus 2y plus z. So here the z is equal to, we are going to substitute the value of x, y and z. See, we have 0 value for z as well, because the basic variable here, while we are departing and entering, we are not considered the z value. So the z value will become 0. So here by taking x is equal to 3, y is equal to 18 and z is equal to 0, we are going to substitute here on the objective function, then it will become 3 into 3 plus 2 into 18 plus z which is equal to 0. So if you go for solving it, then it is equal to 45. See here that 45 is also came here. Then we can say that we have an optimal solution here, and the value of x is equal to 3 and the value of y is equal to 18 and the z is equal to 0, s1 is equal to 0, s2 is equal to 0 and s3 is equal to 1. So this is the process of solving the linear programming problem by using the simplex method. As the name suggests, it is not a simple method to solve the linear programming problem, but we have to follow an interactive process to reach the ultimate optimal solution. I hope it was clear to you. In the next lecture, we will consider the solution of linear programming problem by taking the example of minimization of cost problem. So we will see in the next lecture. Thank you.